Afternoon, everyone. My name is Professor Chris Alden. I'm one of the directors of LSE Ideas, the London School of Economics and Political Science premier think tank on foreign policy issues. Today, we're here to discuss not just matters terrestrial alone, but actually the outer stratosphere and beyond, the outer space. We're very pleased in addition to discussing that, we're going to, this is serves as a launch for our own space policy project, about which I'll say something more in a moment. And of course, this is an opportunity for Professor Daniel Deudney, a professor of political science and international relations at Johns Hopkins and a premier expert on matters of outer space, to present his thoughts on space and international relations. I just want to say a few things about our space policy project and participants who are with us on that, and then I hand it over to one of them, Dr. Stoikos. So first, the space policy project is led by Dr. Dimitrios Stoikos, who's written extensively on this area. He's the editor of Space Policy and International Journal, and has worked for quite a number of years, including doing his PhD at the LSE years ago on international relations in space. So we're very pleased to have him take up a leadership role in that regard. Ably assisting him is Sania Kulkarni, who is working as a project assistant and involved in issues in regards to outer space and the like. And of course, as I've said, we have a distinguished speaker who will be joining us. I'm going to hand the mic over to Dimitrios, who will speak in greater detail about the space policy project and then introduce in full our distinguished speaker. Thank you.
Thanks, Chris, and hi everyone, and welcome to the inaugural event of the LSE Ideas Space Policy Project. As Chris said, this is a new project coordinated by Sonia Kulkarni and headed by me. To begin with, LSE Ideas Space Policy is the new institutional home to space policy, an international journal, a really international interdisciplinary journal that was established in 1985, providing cutting-edge discussion and analysis of space activities. And you can find more information about the journal on our site. More broadly, the project focuses on key trends, developments, and challenges related to outer space activities, with the aim to examine the interplay between space policy and international relations. To this end, LSE Ideas Space Policy seeks to bring together academics and practitioners to share insights into the evolving relationship between space policy and international politics, with the aim to inform space policy decision-making and the public. In addition to hosting the Space Policy Journal, we're also hosting public lectures and events at LSE, as well as publishing commentaries and reports related to space issues. Indeed, the first LSE Ideas Space Policy commentary was published a few days ago, written by Professor Peters on cyber attacks on satellites, with more publications to follow very soon. So please keep an eye on our site for timely analysis on space policy. On that note, we are very happy and privileged to welcome Professor Deudney for our inaugural event on space expansionism, planetary geopolitics, and the future of space policy. Professor Deudney is Professor of Political Science at Johns Hopkins University. He has written extensively on international theory, political theory, and global issues, including nuclear, space, environment, and energy. His book, Bounding Power, Republican Security from the Polis to the Global Village, received the Book of the Decade Award from the International Studies Association. And his most recent book, which I happen to have a copy here, very highly, I don't know if you can see that, Probably you can because of the background, but his new book is Dark Sky, Space Expansionism, Planetary Geopolitics, and the Ends of Humanity. A very provocative, challenging, and intellectually stimulating book that everybody who is interested in space and technology more broadly should read. Without any further ado, Professor Deudney, the stage is yours.
Okay, are you going to put the slides up? Okay, thank you for this opportunity to speak. This contains arguments, as Demetrius said, from my new book, Dark Skies, Space Expansionism, Planetary Geopolitics, and the Ends of Humanity, the paperback version of which is about to come out. Next slide. So this is a large topic, and I fear that this PowerPoint is both too long and too short. I'm going to start by talking about space expansionism as a grand imaginary, some major features of the new cosmos and the new Earth, and then delve down into some misperceptions about planetary geography and space and their implications. If corrected, a few words about catastrophic existential risks, and then plunge in to an overview of solar space, basically geography, and particularly the asteroids, and then an overview of what the space advocates want to do there. And then in section 7, burrow down and actually assess these proposals. Next. So the grand imaginary of space expansionism. Next. This is the product of a large number of people writing really over now more than a century, major figures who have articulated these various ideas, some of them well known, some of them obscure, but remarkably, there is no general one work where this is all pulled together. Next. So what is space expansionism? It's basically three notions. That it is becoming feasible, large-scale human activities in space are becoming feasible. They are viewed as clearly desirable or necessary for basic human interests, and that this movement into space is eventually inevitable. This space expansion is imaginary, is accompanied by an extremely powerful, mesmerizing cosmic narrative, providing a human vocation. It combines ideas from Darwinism and life sciences with scientific technological modernity. And its purest and most extreme form was at the very beginning with Russian cosmism. And you see on the right, there's this reading of the past and the future, the past dominated by globalization, increasing closure and vulnerability. And then there will be a frontier opening of human movement out, colonization and industrialization. Next slide. This has been inspired and nurtured by science fiction. Its advocates view themselves as the leading edge of human progress. They propose to solve Earth problems or ameliorate or escape them. It's also bolstered by a lot of analogies, both geophysical and geohistorical from Earth history. And it also serves as the ideology of a transnational movement and network which hasn't received the attention that it deserves. The members of this community call themselves fondly the space cadets, and they view themselves as the vanguard of the human species. But the question we're going to ask, do the ends justify the means? If the end is great enough, then presumably any means are justified in the thinking of these people. Next. So this is the largest and most ambitious grand narrative of Enlightenment civilization. It's the fullest futurism of scientific technological modernity. This is the Baconian project of scientific technological modernity, a new method of modern science to torture nature to reveal her secrets, and then second, to apply this new technology to transform and elevate the human estate. Part of this program from the beginning has been to refashion the Earth through terraforming and mega engineering. Tsiolkovsky himself talked about population going up to 400 billion people on the planet by the time this is fully done. And I call this the Fuller Earth program, which basically space expansionism continues. Tower of Babel there on the right. Next. This is nested in a great debate on planetary Earth that has occurred. Globalization caused by rising interaction, interdependence, and vulnerability is the major pattern. And a crucial juncture occurred in roughly 2 decades in the middle of the 20th century when we shifted from global Earth to planetary Earth, marked by the emergence of new super technologies, nuclear weapons, rockets and satellites, digital computers, and DNA mapping and biotechnology, as well as this is the period when the great acceleration occurs and the Anthropocene begins to be dated. Obviously, many different debates about specifically where, but this seems to be the most popular. But note that the rates of technological maturization of these new super technologies, fortunately for us, have been very uneven. But the rest of them are coming. Next, please. So as to actual activities in space, there is no general assessment that has been done, and there is no general assessment or critique of space expansionism, which I attempt to do. And so my main claims are that space thinking and space expansionism in particular are marked by geography errors, misleading geohistorical analogies, and slanted geopolitics. And I will basically be correcting some of those, giving us a very different picture of it all. These can be all assessed because they are practical in character. If we do X space project, then Y will result. Next. So space expansionism has a lot of internal variety. There are, I think, 3 main programs. No one sorted this out, and there is kind of a chaotic intellectual horizon here. The first of them I call the Habitat Tsiolkovskian. This is the earliest, it's the vastly most ambitious, but it's also the least accomplished. And for the Earth space, they want big infrastructures, urbanization, orbital nets, belts and rings that would eventually create the 7th, depending on how we count the moon, continent that I call Orbita. For solar space, there's going to be resource extraction and colonization essentially forever. But we also have the military, the von Braun program, which is to weaponize to secure the nation states. This has been partially pursued for Earth orbital space. Its rival has been what I call the planetary security, the Clark-Sagan program of arms control science, infosats, cooperation, Earth identity. This too has been partially pursued in Earth space. And so this thus gives us what I call the first great debate in space between these 3 positions. And a good part of the book, which I'm not going to do much of here, is an argument about why geopolitics, properly understood, shows the superiority of the Clark-Sagan position. Next. So let's say a few words about the larger context, the discovery of deep space and deep time. Next. To start, we should note that most of human history has actually been appropriately called the Sky Age, in which people attributed vast importance to sky phenomenon, but were essentially ignorant of what they were looking at. We see this in religion. Power gods were in the heavens. Giant astronomical megastructures in very poor societies were built, the one on the right in Mexico. Skycraft was a part of statecraft. Astrology was pervasive. Our fate is in the stars. Eclipses, omens, and comets. Eclipses and comets were seen as omens. Also note that during this period, astronomy, the earliest exact science, emerged, great advances in mathematics and measurement with practical applications in calendars, navigation, and map making. But the world was very diverse in its cosmologies and astronomies. Next. So then we have the early modern Copernican through Newton revolution. The Earth is a globe. The Earth revolves around the sun. Simple laws govern it all. And the fixed stars are sun-like objects at great distances. This was transformative cosmologically. Subsequently, in the 20th century, more recently, we see the discovery of deep space. The current estimate is that there are 2 trillion galaxies, each of which contains between 2 and 400 billion stars. So there has been what we might call the infinitesimalization of humanity and the Earth, something recognized in the wake of the Copernican revolution. Advances in astronomy have to be viewed as unrivaled in their magnitude and ultimate significance. All space activities, perhaps to say the obvious, depend on accurate astronomical knowledge, essentially a task of mapping. So there have been these great cascades of discovery. We all see these. There's extraordinary pictures and so forth. Next. But there are 2 space discoveries that haven't been put at the top of the list as they should be. The first is what I call the cosmic desert. This is the discovery that the cosmos is harshly inhospitable to human life, and that Earth habitability depends on multiple cosmic influences. This means there is a permanent possibility of cosmocide, the extinction of humanity from cosmic forces. Next. The other great discovery that never gets enough attention, that should be a second on the list, is what I call Oasis Earth. And for many trillions of miles in all directions, Earth is a very special place, teeming with advanced life, some 2 billion species or so. And compare this with the early modern expectations and anticipations that the solar system was teeming with life and indeed intelligent life. But what is the implication of Oasis Earth? Does it mean we should protect the Earth and or expand into space? Next. There's also been a rediscovery of the Earth that has occurred during the space age. Norman Cousins captures this well. Not that man had set foot on the moon, but rather that he had set eye on the Earth. During this period, there's been a revolution in Earth science. Before we had separate sciences, oceanography, geology, and so forth, but now we have this new Earth system science, ESS, in which the geopolitical parameters are understood to be highly interactive and shaped by organic life across deep time. So solar planetary science that we're all seeing, these wondrous images, it's really the Copernican model with a lot more detail. But during this period, there has been a Copernican-like revolution in understanding the Earth. Next. So what are the implications of this rediscovered Earth? Life is of the Earth, not on the Earth. In many ways, it is one organic body-like entity, but it is marked by extreme complexity and emergence, which means that the outcomes are not reducible to their component parts or their interactions. As Jonathan Shell memorably put it, the Earth is an epistemologically unique object. So what are the implications of this? It casts doubt on the Baconian technological progress. There are limits. We cannot fully understand the Earth and predict the impacts of our activities, or can we fully master and control it? And note that this imaginary of space expansionism occurs before the space age and is being undermined by scientific advances during the space age. Next. So let's say a few words about space and planetary geography, some of errors, corrections, and implications. Next. First, there's a fundamental geographic misperception. When we say go into space, means to leave the planet. This is inaccurate. Outer space immediately around the Earth, terrestrial Earth, is part of the planet Earth. Why? Because it's fundamentally shaped by its gravity and magnetic fields. So the astrosphere is the space part of the planet Earth. So the Earth is onion layered with the astrosphere on top. And note that all space activities, or almost all, have not really left the planet yet, and that the astrosphere is vastly smaller than solar space, which means that interaction and interdependence are going to be vastly different in these two realms. Next. The next geographic misperception is the idea that all space is large. Surely solar, galactic, and cosmic space are incomprehensibly vast in size. But the correction here is that the astrosphere, especially the lower levels, is quite small in practical terms. What's happened is that we've conflated geophysical distance with practical and effective distance. It is true that the absolute volume of the astrosphere is larger than that of the atmosphere, but the velocities necessary to stay there, 17,300 miles an hour, 34 times as fast as a commercial airliner, are proportionately higher. And so effective distance, meaning travel time between 2 points, is lower in the astrosphere than in the atmosphere. So we should think of the lower astrosphere as like a tunnel, 45 minutes to anywhere else on the Terran surface. Next. Another feature of space geography generally that doesn't get adequate attention is the extremity of natural violence. This is because speed kills. Collisions of high velocity objects release immense amounts of energy. The equation is mass times the square of the velocity. There are three implications of this. First, compared to terrestrial environments where we have natural violence such as storms, blah, 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 Earth is exceptional and not readily weaponized. Second is that we have, as part of nature, asteroidal and comet, etc., collisions, disasters, catastrophes, and extinction possibilities of cosmocide. And third, very relevant to our story, is that extremely violent anthropogenic weaponization is always ready at hand. Next. Another point about planetary geography that's been very misleading, it has to do with ocean analogies. Earth orbital space, the lower parts particularly, are crowded and degraded to the point where further employment is jeopardized. About half the 8,000 satellites that have been launched are still in orbit. About 5,000 and some 2,500, I'm sorry, about 5,000, this is confused, let me just step ahead. So this is a combination of satellite debris, old satellites from ASAT tests and unintentional collisions. There are about 23,000 objects, 10 centimeters rather, in size, and then vastly larger numbers of smaller ones. So this is very unlike the early modern ocean, so often analogized by the advocates. It is like the contemporary Mediterranean, Caribbean, or even the Aral Sea. And so I ask a what if. I'll be doing counterfactuals here to help illustrate at various points. What if half the ships ever launched were still speeding around the ocean surface, potentially colliding catastrophically with other vessels? Next. Another error is that the frontier analogies are misleading. They're not immediately and readily degraded and crowded the way we have space already. Frontiers have both and choice horizons, but the astrosphere has either choice horizons, difficult choices of competing activities. And overall, human space activities have diminished, not intensified, have intensified, not diminished planetary closure. Come back to that point in a minute. Next. So another set of geography errors have to do with how we define space weapons. We now say space weapons are weapons in orbit or used against objects in orbit, which excludes ballistic missiles from being space weapons. But ballistic missiles, I argue, are inherently space weapons because they exploit the unique features of space, the vacuum and hence no friction, to do what they uniquely do as weapons, which is to go very fast. This was recognized from the very beginning. General Walter Dornberger, 1942, after a successful V-2 launch. This is the first day of the space age. We have invaded space with our rockets, and for the first time have used space as a bridge between 2 points on Earth. So this changes the entire landscape of space activities and their impacts. The Cuban Missile Crisis of 1962, the most dangerous moment in human history, this was a nuclear crisis triggered by the speed of the missiles. The second implication would be that one of our largest space programs is actually the nuclear weapons space transportation system. And third would be that most nuclear weapons arms control is actually ballistic missile space weapons arms control. We don't really regulate the warheads per se. We do the delivery vehicles, most of which are ballistic missiles. Next. And so the biggest negative impact of space activities to date has been the increased risk of nuclear war. Our first real existential threat has actually been exacerbated. But also we would say that the biggest positive impact space program, not even recognized as a space program, has been the nuclear weapons ballistic missile space weapons arms control. So there's a great irony here. The advocates often accuse, I think accurately, of exaggerating the impacts of space, but actually they have significantly underestimated the impact of actual space activities. Next. So in sum, the space expansionist practical geography is inaccurate, and enclosure has actually been intensified. Next. So why do we misperceive so fundamentally? In part because it's radically alien to the terrestrial human experience, the velocities, the radiation, the weightlessness, also that it's essentially invisible. Extremely distant objects, such as the center of the galaxy, the Milky Way, as in the image there, sprawl across the night sky, seem close, while very near objects, such as satellites, are almost completely invisible. Next. What if satellites, like aircraft flying high in the atmosphere, produce visible contrails, these vapor trails? This is impossible, but if this were the case, we would see a dense web of orbital tracks, a net enveloping the terrestrial Earth. This would convey the reality that we don't see, which is both how close and how enclosing space activities are. Next. So a few words about catastrophic and existential risks. Next. So these new superpower technologies of nuclear, biotech, ASI, and nano have great potential benefits, but also high risks. They're potent double-edged swords. Can humanity reap the benefits without succumbing to the risks? Space expansion is nearly universally viewed as a solution to these risks, but my claim is that space expansion will actually generate new risks while making others more difficult. And the fan of the future there of Kenneth Boulding, the expansion of the futures we have before us. And of course, the utopian ones are all propelled by these super technologies in these scenarios. Next. I want to focus specifically on transhumanism, cyborgization, and ASI. We have a widening cone of possibilities in which there's going to be many menaces and monstrosities, such as stratification, militarization, collectivization, fragmentation, and radiation. If humanity wants to survive and slowly enhance itself, these technologies will have to be steered and restrained. I represent that here as the path of preservation constituted by restraints through this cone of possibility, a subset of it. But how do we conceptualize this? Implement, sustain it? We have weak epistemology in forecasting and assessing. We have resistance from powerful actors. And then I'm going to ask the question, given all of this, can we maintain these in space? And if we can't, space expansion will be a multi-sided threat enabler. Next. Some images of this, the science fiction technological imaginary. It's not that aliens will come, it's that aliens will be descendants of biological humans with these technologies in space. Next. Cyborgs as well. Next. So let's look at solar space and the asteroids in particular. Next. We start by the immensity of it, the Earth, tiny little dot in there, and these larger bodies with much larger distances between them. But the actual area of space where there's solid surface on the right is really only about 2.5 times that of the Earth. I think a very revealing presentation. Next. So what about these asteroids, planetoids, minor planets? Most are in the main belt. Some 900,000 of them have been discovered. Our interest is in the near-Earth objects that cross the Earth's path. We see these in the images here. These are part of the new Earth history. We understand these collisions have played important roles. Next. So some historical collisions, Chicxulub wiping out the dinosaurs, the asteroid Winter, one of the 5 great extinction events, 100 million megatons of energy released. Next. The most recent historical, Tunguska in 1908, obliterated an area the size of Washington and New York. It was somewhere between 15 and 30 megatons, puny in comparison. But what if this had come a few hours later and struck populated parts of Western Europe? With the entire course of 20th century politics and technological development and space priorities significantly different? What if it happened in 1958 at the same place? It might well have triggered a nuclear war. Next. And then we have Tunguska, most recently in 2013, some 300 to 400 kilotons, a baby bomb in comparison. But note, coverage of this was extensive, but it was never brought out that this was a major Russian and Soviet nuclear weapons center. What if this object had been Tunguska-sized and caused the release of large quantities of radioactive material into the biosphere? Next. These objects strike continuously and have been tracked with the nuclear weapons early warning systems. They were initially confused with nuclear explosions in near-Earth orbital space. Next. So the natural collision risks. It's inevitable, again, eventually. It's not whether, but when. The good news is that the less frequent ones are the bigger ones. Tunguska sized every 100 to 500 years. And of course, these collisions can be averted by human technological interventions, so-called planetary defense, in contrast to other geophysical perils, which we have no way of actually potentially stopping. Next. To get a sense of the violence potential here, all nuclear weapons, 13,000 megatons. Near-Earth objects alone, not the bulk of them in the asteroid belt, is 86 million megatons. And so if we develop asteroidal deflection technology, we are tapping into a destructive weapons potential that is roughly 7 orders of magnitude greater than nuclear weapons. So what might be done? Well, Cole and Koch said, well, let's make planetoid bombs to extend deterrence. Most say, let's have planetary defense to monitor and deflect. Sagan and Ostrow, however, point to a deflection dilemma, that there will be an increased probability over the natural rate because of intentional human use, and therefore don't do anything until we have world government. My claims are that if we mine asteroids, we will have weapons, and second, that intraterrestrial use is unlikely, but interplanetary use is likely, and therefore Clark and Sagan and Ostrow have misplaced this threat. Next. So the implications here are that our environment extends across the solar system. It's utterly random if, when, and where, and that human asteroid choices will profoundly shape the future of the planet and the species. Also note that these island analogs so widely used are very misleading. Islands do not move, do not collide with habitats, and cannot be altered in their environments to collide. But asteroids move, collide, and can be altered to collide. Far more misleading than insightful analogy. Next. So let's look at what they want to do very quickly. Next. So it would occur in stages, small colonies on Mars, beginning of orbital asteroid technologies. Then we would have larger colonies and have more movement, and then would have Martian urbanization, and then eventually out into the much larger space of the Kuiper Belt and the Oort cloud, where we would have interstellar voyages. This is obviously something that canon is in the book, elaborated in vast detail, but this is roughly, their sort of vision. that is assuming that all goes well and there are no political problems. Their success scenario. Next. And of course, they give us this narrative. They have all these resources in space. A cartoon here capturing that nicely. Next. So let's look at the case for space colonization. The advocates claim vast frontier expansion benefits, valuable technological and cultural innovations, great economic growth, the expansion of freedom and cultural diversity, the possibility of escaping Terran world government, and there's no imperialism, population displacement, or ecological despoliation. Colonies like on the right, we will basically fill space with. Next. But their biggest argument, really, I think, best argument, is about planetary vulnerability. The planet is fragile, limited, and vulnerable. Resources of minerals and energy are in short supply versus the supposedly unlimited quantities in space. These mega disasters might produce human extinction. And so one of their best lines is, all of our eggs are in one basket. And the dinosaurs went extinct because they did not have a space program. The solution, become a multi-planetary species. All space, almost all solar space thinking is pro-colonization. And what I attempt to do is to open what I call the second great debate on space, the pros and cons of human space expansion. Next. So let's look at this. If we could do it, would we want to? Next. First of all, feasibility questions. The biggest has to do with artificial ecosystems, which I should have put on this slide, shouldn't I? Also, there's an opportunity cost questions. Founding a self-sustaining colony on Mars will cost at a minimum hundreds of billions of dollars. Alternatively, how might such resources be used to other Earth problems with more urgent implications? There's a moral hazard problem. The mere prospect of Planet B reduces pressure to solve Earth problems. There's also a time horizon mismatch. How long will it take to build a self-sustaining colony versus when the Terran problems must be addressed? And there's great uncertainty. Whether success is possible might not even be known for a long time. Next. But I want to focus on geopolitics, and this is a kind of a summation of a lot of ideas from international relations theory about system structure, units, and material context. So there are four factors: proximity, interdependence, and interaction first, variation of high to low, and this shapes whether anarchy is tolerable for security. Then we have distribution, balance to concentrated variations. This shapes whether we're going to get hierarchical or plural, in my language, Republican arrangements. Then we have distinctiveness. The military potential is ready to hand, high to low. And that box should say something like the degree to which you can regulate it without regulating civil life. Then we have a fourth unit level regime type variation, like to unlike. What this shapes levels of misunderstanding, misperceptions, and proclivities to conflict and cooperation. Then we have unit level regime type, hierarchical to Republican, and this shapes the level of individual freedom. So that's my little model, and we're going to now apply it. Next. So we have some propositions that the solar archipelago will be geopolitically malefic. There'll be a perfect storm of reinforcing factors that will make it prone to total war. Let's look specifically. Colonies large enough to provide extinction risk insurance are likely to be politically independent. This will produce an Antarctic system structure that'll be reinforced by fragmented topography, great distances, and great differences of circumstances. Second, to remind us, this is extremely violent environment inherently. Third, this is going to be marked by open frontiers, full frontiers that will be open, which will arguably be prone, like so many frontiers on Earth, to violence and perpetual shifts in power distributions. Fourth, the units are likely to be very different, differences in circumstances, and then, of course, with species radiation, whether undirected or directed. And so five, in terms of my model, violence interdependence will be intense. While effective distance will be increased, annihilative saturation of inhabited space due to the volumes of violence from nuclear weapons and planetoid bombs will be vastly larger than the minuscule inhabited space. That is to say, the actors will be readily able to destroy one another in this world. Next. So in the situations of intense violence and interdependence, this is one of the themes of my book, Bounding Power, is that exiting anarchy and establishing mutual and restraining government is necessary for security. But in the solar archipelago, this will be nearly impossible to achieve due to unit level differences, distances, and difficulties in surveillance. Also, space settlement civil military distinctiveness will be very low because asteroid moving is going to be a basic civil technology. 8, a big part of the book, can't talk about this, very fascinating debate. We're likely to have totalistic hierarchical government in space settlements. 9, island Earth in the solar archipelago, which is what we will be reduced to when we have large numbers of humans living across the solar system, will create strong pressures for highly hierarchical political consolidation on the Earth. So overall, the solar archipelago is going to be highly prone to total war. The real state mode of protection, my term for pure power politics realism, will be prevalent. So let's reverse some of these slogans. Humanity's eggs will be in multiple baskets, but egg smashing with large rocks will be easy and likely. The dinosaurs survived for several 100 million years because they did not have a space program. Next. So also back to this point about the restraint reversal briefly, we have this narrow cone, the narrow path of preservation. This all depends on effective restraints of these super technologies. Doing this on the Earth is going to be difficult. It's going to require architectures of restraints, reversals, regulations, and relinquishments. Sustaining these restraints in a solar archipelago of many different worlds with these conflictual tendencies will be vastly more difficult. So, if significant space colonization occurs, then species radiation in the silicon succession begins to approach the inevitable, assuming that is possible. And thus, the extinction of Homo sapiens also begins to approach the inevitable. But the advocates will say, oh, well, that's unfortunate, but this will assure the survival and expansion of Earth-oriented life. Next. So, some conclusions. Space colonization should be relinquished in the sense of avoided for at least several centuries and until after the nuclear, climate, biotech, robotic, AI, and nano revolutions have run their course, and we have, or not, restraint regimes. This colonization poses the threat of astrocide, which is my term for extinction of humans that result from space colonization. There is no middle way. Any colony capable of providing catastrophic protection will be large enough to be independent, and once independent, anarchy, war, etc. will be more likely. If, or as, the prospect of colonization becomes more real, I believe the downsides will become evident, and that significant opposition is very likely. You might ask, is there a departure dilemma? Are we doomed if we stay and doomed if we leave? Yes, but the vastly different timescales. Let far distant future generations decide. Can space colonization be stopped? A big question. If it is inevitable, as the advocates claim, then space expansionism must be judged as among the darkest, in the sense of most likely lethal, of all the imaginaries of scientific technological modernity. Next. Running out of time here, but I will just briefly note that there is this alternative Clark-Sagan program that we should be pursuing. I call this an Earth-oriented space program. Next. So what do we want to do? We want to get rid of ballistic missiles and not do orbital weapons because of the dangers of nuclear war. We don't want to build large orbital infrastructures because this will reduce the prospects of hierarchical world government, an argument developed in the book, not in this talk. We want to relinquish colonization of Mars and the asteroid to avoid the astrocide scenarios. What about national or corporate asteroidal alteration I also believe we should relinquish because it reduces the probability of military use. And with regard to asteroidal consortium, I think that we should actually do this in an expanded way to have a planetary defense system. To do so with a minimum of military risk. As to the Outer Space Treaty, we should strengthen, provides a framework for civil space activity, arms control, and debris mitigation. We should do more Earth science, and then off the slide here is more astronomy as well. This is an ambitious program. This better serves the interests of humanity than either the von Braun or the Tsiolkovsky programs. Next. Last slide. This is really the last couple of sentences in the book. I'll just read them. We are now saved from the consequences of our illusions by our incapacities. This is unlikely to continue indefinitely. Survival increasingly depends on our ability to anticipate consequences with good futurism and our ability to say no. The only inevitabilities are that we must choose, that our foresight, steering, and restraint capacities are limited, and that we will live or die with the consequences of our choices. Next slide. The end.
Thank you very much, Professor Deudney. That was fascinating, very interesting ideas. I think we already have some questions from the audience, but feel free to post your questions. The first one is by Mos Joshua. Thank you for speaking us today. A question for audience Q&A time. Space is an extremely costly and vulnerable environment for human structures. A military catastrophe between powers would surely push popular support even further away from space exploration. How do we prevent such conflicts above and beyond international law, as it is likely the militarizing space may not be abided by certain actors?
Well, this is a topic that I did not have time to address here, and that I extensively do in the book. And this is, of course, an ongoing topic that a great many people have been working on. It's really a simple question of establishing an adequate regime. And of course, we can lay out what the preferred arrangements are, but getting to the preferred arrangements requires that the leading states and the leading actors actually are willing to do this. And that's something that we, of course, haven't had. Look at the situation with catastrophic and existential risks that we now have already got at hand. Nuclear weapons and climate change, our record of adequately restraining in these areas is not very good. And so I say, why would we start another one with space given our poor record so far? I would also add, however, that I do believe that civilian and scientific activities in space, and particularly things like the International Space Station and even space tourism, could potentially provide a break on militarization, because it is an either-or choice to a significant degree. That if we have the weapons trajectory, more debris, more degradation, other uses will be excluded. So I'm hopeful that these civil uses will be a positive factor in that perennial equation.
Thanks, Professor Deudney. We have a second question from Asley Otu. Should we try and use space to bring solutions to Earth to analyze data to solve some climate-affected areas?
Oh, absolutely. There's a whole part of the book on this, and of course, this is widely known. Part of the discovery of the Earth that I mentioned earlier, the rediscovery, has been made possible, not entirely, but in part, by this fleet of satellites that we have been using to gather data about the planet's systems. And this is something that we don't do enough. This is something that we need to do more of, and is a major plank in the Clark-Sagan Earth-oriented space program.
Thank you. We have a question from Dr. Jill Stewart, former editor of the Space Policy Journal, who is based at the LSE. Thank you so much for this presentation. I wonder if you have an opinion about whether we should be seeking to make contact with potential extraterrestrial intelligence, or if you feel that we should also be avoided at this time in humanity's history.
Well, that's a fascinating question that I do not address in the book at all. What I do point out in the book is really a kind of a summary of the science on this. The expectation, I think, as I mentioned earlier, was that there would be not only life, but intelligent life in abundance in this solar system. And so there has been a non-finding, and the best thinking about the existence of extraterrestrial intelligence in this galaxy is that it's likely to be very rare. And beyond that, we're getting different types of informed speculation. But my general tendency is, no, we should not be attempting to communicate with them. The reality is that if other intelligences emerged in this galaxy, that by now they would have evolved biologically and technologically to forms that would be completely unlike what humans are currently like, and that they would have complete mastery over us if we were to encounter them. And my sense is that we should just get our house in order, get our nest cleaned up a bit. But that's, different people have different gut takes on that.
Thank you. We have a question from Derek West. Space tourism is around the corner. Who will provide order when space tourism turns violent?
Well, I agree with you that space tourism is soon here, and these facilities will, of course, be privately owned, and so the violence that might occur inside them, will be the matter for the owners of those structures. I don't see a situation where we will see violence between different space tourism infrastructures simply because they're so vulnerable and so expensive.
Thank you. We have another interesting question. Does the Artemis program push humanity in the right or wrong direction in space? By Ms. Johnson.
The Artemis program is something that was cooked up in the United States that the Trump administration really pushed, and that the Biden administration has continued. And this is, I think, a major step backwards. And what this does is says that when the United States is going to go to the moon, and if you other countries come with us, you sign these accords, and according to these accords, the area around our activities, our facilities, will be treated as a sort of de facto extension of our authority. I think this is a terrible mistake. I think that, and this is something the Clark-Sagan program has emphasized all along, that if humans are going to go into space, and I don't think there's really a whole lot of purpose for humans in space if we don't want to colonize, but there'd be some, that if humans are going to do things in space, they should do things together in space. We should not establish bases on the moon unless they are cooperative and open and devoted to international science. The model here would be the Antarctica Treaty coming out from the International Geophysical Year. This is a proposal that many have made in different versions, and I think that it's clearly a superior path to the new arms race and the new space race that the great powers, particularly the United States and seemingly China, seem to have embarked upon.
Thank you. We have one question from one of our students, Poom, who does his dissertation on space. Even with Earth-oriented space programs, with an Earth-oriented space program, could the orbital commons and civilian peaceful developments ultimately become the source of conflict instead, given that space technology is inherently dual use? Even just measures against space debris can easily be repurposed for military use if the limited orbital positions become too crowded, such as the contested geostationary orbit. Would actors move to secure commercial interests anyway?
Well, excuse me, I think the basic thrust of this question is right on target, that if we build the capabilities, to, as you say, to get rid of space debris or to have satellites that can change their orbits rapidly and accurately, then we've got a weapons technology. And indeed, people have talked about creating space debris, putting gravel clouds in orbit. There actually was an early test, West Ford, it was called, in which the United States put a cloud of metal needles in space. The United States also detonated thermonuclear weapons in the Van Allen radiation belt in an attempt to see if they could augment the level of radiation and that it might serve some sort of function for ballistic missile defense. So it's inherently violent. And so the key point is that Earth orbital space requires a regime to regulate these activities in the same way that we have to have air traffic control regimes or that we have automobile traffic control regimes. It's because the density of activity is just too great to have anarchy. So that's not to say that we will do that, but if we don't do that, we will degrade the environment and then less will be possible.
Thank you. Another question on space mining. Thank you for this presentation. Do you envision a state whereby those on planet Earth become dependent on space mining for resources, for example, copper and other such minerals? If I remember correctly, Jeff Bezos and possibly other space expansionists are aiming to have industrial manufacturing on inner solar system planets. How feasible is this by 2050? Would I assume that economically this isn't possible before 2050? What do you say?
Yes, you're right that there is this vision of mining, and there is a lot of metal, particularly in some of the asteroids in the main belt. And this has been extensively talked about, but it is all view graphs at this point. We have no idea what the real economics of this is like, but I think that it is realistic that over time it will become both technologically feasible and economically appealing. Will this happen by the middle of this century? I'm skeptical. One of the tendencies of space advocacy is always to misjudge the time frames. And while the economics of minerals on the Earth, is still going to be getting successively more scarce, I don't think that it will be sufficient to propel significant asteroidal mining. But, I could be wrong. It's hard to predict, particularly when you've got actors who might be willing to spend enormous amounts of money that they don't expect a rate of return of anything from. One additional point on asteroid mining that I don't think has been noted, which is that it's going to be much more easy to do than serious colonization. It's likely to occur before successful colonization of any scale. And that once terrestrial actors start mining asteroids, then terrestrial actors are going to be opposed to space colonization. They will see, I believe, that these colonies will be eventual rivals and that Earth will want to keep unique access to these capabilities, these resources.
Thank you. Another question, what are the economic and social benefits of a spaceport in local communities? I think this highlights another dimension of those who espouse an expansionist agenda, perhaps.
A space board in a local community?
What are the economic and social benefits of a spaceport in local communities?
Oh, a spaceport.
Yeah.
Well, that's something that is being debated all over the planet. There seems to be a kind of boom, so to speak, in building spaceports. There's this kind of gold rush bonanza mentality, and everyone's trying to get on board. My thought is that if I lived in an area, I would not want to have a spaceport nearby because, of course, some of these rockets malfunction and parts of them, crash in the surrounding areas. There's also noise issues. There is pollution from the burning of these rocket engines. And then the simple complex itself is typically displacing ecosystems of, in most cases, marine adjacent wildlife. I'm a strong believer in E.O. Wilson's vision that we should keep half the world wild, and that we should not take away any more wild area unless we rewild existing areas of use that have been degraded.
Thank you very much. Another question, do you believe there is a benefit to having commercial space stations in orbit? The reason why I ask is because whenever I hear people say the International Space Station, where do you go? The International Space Station, I don't believe the International Space Station is as international as stated, especially when you see that only a small handful of nations have had access to it and only limited to certain experiments. Moreover, the ISS is limited when it comes to international cooperation with certain nations due to political factors. An act of Congress from 2011 does not allow Chinese cosmonauts to go to the ISS, for example. What do you think?
Well, what is the purpose of the International Space Station? What goes on there? The advocates are always telling us that there are all these experiments to do, but the scientists will always say, don't put humans in space to do science. It's vastly cheaper to use robotics. The one thing the International Space Station can do scientifically that is unique is study the effects of the space environment, particularly weightlessness, on humans. And that really is the main thing that goes on there. I take your point completely that it's not as international as the label might suggest, but remember that the program was launched, and I was an advocate of this. I did activist work during the period leading up to this, wrote in favor of it, testified, and so forth. And the logic that I and others advanced was that this would be a way in which the United States and the Soviet Union, Russia, could take their previously antagonistic space programs and meld them together to a significant degree. And so there was really a political rationale for this, that we had the idea that once this joint expenditure had been made and both sides were dependent on it, that would provide a break on the deterioration of their relationship. And as to whether that's happened or not, it's hard to say, but it is still a joint operation. We'll see after this Ukraine story unfolds. But my thought is that, finally, on your point about China, that was a crazy move on the part of the United States. We should have welcomed China. And of course, Americans will say, oh, they'll get our technology. Well, A, they're already getting our technology, and B, the technology in the space station is not really that advanced. But most importantly, once the Chinese were frozen out, they then did their unilateral program. We had another example of this short-sighted American space policy thinking back in the space shuttle period. the space shuttle was going to be, the supposedly great new way to get to orbit, and it was going to serve all purposes, the military as well as civilian scientific launches from American and other users. And the United States said, oh, well, we can't have the Europeans who wanted to participate. We can't have the Europeans involved in this because they will technology transfer and secrecy and so forth. And so what did the Europeans do? The Europeans basically turned and expanded their own launch capability. So we have a long record of bad space policy, not all of it, but of this type of pattern. And we need to go back to the earlier visions that so well articulated in the Outer Space Treaty and at various junctures during the Cold War, that science should be the primary activity and that this should be done on an international and cooperative basis.
Thank you, Professor. Just to take advantage of my position, and because we're speaking about US space policy, I don't know if the current US government has read your book, but we have seen a recent shift in US space policy priorities. We've saw very recently the US announcing a self-imposed ban on debris creating anti-satellite tests. We also saw this more emphasis on climate research from space. How do you assess this shift in US space policy?
Well, it's the difference between the Republicans and the Democrats, to a first approximation. The Republicans tend to be much more oriented towards the militarization scenarios, and the Democrats, are much more interested in environmental and scientific enterprises of this sort. So the Biden administration is, doing another part of the Clark-Sagan program. Look, there's been a war of attrition, in the trenches in the policy domain that's gone on now back to the 1950s. And it's essentially the same arguments over and over again. And the relative power of the different positions, shifts on the basis of multiple factors, including extraneous domestic ones, but also on the character of the international environment, of the rivalrous nature or not. And so those have been, and they will continue to be, realistically, the factors that are going to shape whether policies of this sort are pursued.
Thank you, Professor. A former student of mine, Alex Jamal, should private civil actors successfully utilize asteroid mining? Will that widen the gap between rich and poor, eroding the hard progress made, or help narrow that gap even faster? I think that's also a comment on capitalism, which you elaborate on your book. What do you think, Professor?
Well, that's an important question. And as I said, I didn't in this talk about the Earth alternatives at length. And look, the fact that two of the richest people on the planet, are doing space surely is an indicator, of where this is taking us. And to the extent that there is great wealth to be gained, then there will be further inequalities. Frontiers, have this reputation of being places where freedom benefits, but they also have been places where there have been great unequal distributions, kind of first come, first serve, who can steal, who can coerce more effectively. And we're basically getting another version of that occurring now. And of course, this is something that, again, that we've seen with regard to these terrestrial common spaces, the law of the sea treaty. There was this recognition that there was all of these mineral resources on the seabed, and the powerful and wealthy countries wanted to let their corporations do it unilaterally, and the poor countries, the so-called third world, as it was called in those days, said, no, you can't exploit this new commons on the planet without our participation. We need a share. And so the International Seabed Authority was created that was supposedly going to license and regulate and receive various revenues. So it's the same problem over and over again with these new spaces. And it just comes down to a question of political will and the ability to mobilize on these alternative visions.
Yeah, thank you very much. Another question, talking about going back to science, is it realistic to think we can really put the genie back in the bottle?
Well, yeah, that is a major question with regard to this type of thinking that I've laid out here. You know, I talk about these super technologies and the necessity of having restraints, reversals, relinquishments of various sorts, and to note that we have been doing that all along on Earth with various technologies to varying degrees of success. And we would importantly distinguish here between scientific knowledge, which I don't think we can put the genie back in, and even really technological knowledge, engineering know-how, if you would, which also, once created, is very difficult to reverse or effectively regulate. But the actual building of things, of artifacts, of apparatuses, of infrastructures, that's where regulation is appropriately focused, and that's where we have a long historical record on the Earth of regulating techniques, of regulating the things around us in various ways. You know, think about the automobile initially. It was extremely noisy, and so we had retrofitted with mufflers, and we mandated it. And then we had all of these safety issues, and so we have seat belts and airbags, and the glass has been made so that it doesn't break in shards. So we're continuously retrofitting on the basis of understandings of unintended negative consequences and risks. So it's not that this is a new thing, and it's just that we have to probably get a good notch better at it. And, you know, people talked about climate change and, oh, we have to change our behaviors. Well, what we really have to change is our infrastructure. We have to change, you know, this giant apparatus of pipes and, you know, wires and so forth that we have built in the past on the assumptions that are no longer true about the impacts of it on the planet. And so, what is the solution set? Well, we electrify. We have photovoltaic cells. You know, we just have distributed batteries. We reconfigure the grid. You know, we have much better insulated buildings and houses and so forth. So that's the regulation of techniques, the regulation of these infrastructures. And with regard to nuclear weapons, you know, even though the will to do this has been absent, we've done it. At the end of the Cold War, we had an enormous drawdown. We had verification of this. We had all of this cooperative dismantling of this parts of this doomsday device. So we have a strong track record. All we need to do is get the will to do it.
Thank you very much. We have one last question from the audience. As the world is currently, we have one more. As the world is currently experiencing supply chain disruptions due to COVID-19 and geopolitics and price of raw materials going up, would investment in the space industry still be valuable in the long term? For example, satellite internet provider Telesat has had to downside its original low Earth orbit constellation plans due to these factors. What do you think?
Well, that's a real interesting question. And, you know, there are kind of two different sets of factors here, at least, in play. You know, one is the general economic situation. And much of this capital, you know, it has come from people, you know, who are venture capitalists in various ways, who have large quantities of disposable wealth that they're somehow hell-bent on making even more. And they, you know, invest in risky edge technologies. I don't think that that's going to significantly diminish. You know, even if there's a recession, these people are extremely wealthy. It'll diminish somewhat, but it's not going to go away by any means. The other factor, of course, is do these different satellite networks actually generate revenue? And that, you know, remains to be seen. you've had record cases of this. The iridium, system, was never really that economically viable. And there's rivalry. You've got terrestrial cell phone towers that are connected with fiber optics. And there also are uncertainties about these constellations in low Earth orbit. Already we're seeing a crowding effect, with astronomical activities. And, how long are these little gizmos going to actually last? And, we've seen already that the solar flares and solar eruptions that cause the atmosphere to balloon out are diminishing their viability. So there's a lot of factors. If I had money and we're trying to maximize my rate of return, I would not invest in satellite internet networks. But what do I know?
Thank you. I have a question. Today was the first day of the open-ended working group on reducing space threats in the United Nations. What is the future of arms control, and how do you assess this recent development with regards to the open-ended working group?
Well, I think it's a valuable step forward, and it's sort of a point that's always to be made on this type of thing. It does come down to the priorities that the political actors have. And, one of the important features of the world today, several of the other speakers have alluded to, is this great stratification. But the poor countries do have numbers on their side, and they do have significant voice in these international organizations. And so to the extent that they can come to a consensus and push it, that would be an enormous step forward. And I think here about the nuclear ban treaty. The nuclear ban treaty is not something that any of the nuclear powers pushed or want, but nevertheless, it came about. Of course, the implementation of it, is going to be a different matter. But that's a good example. The land mine ban treaty. Outside the great powers, there is influence, there is power potential, and so it could happen that there would be a countervailing tendency here. But it's really the United States and China and Russia. It comes down to these three, bad apples.
Yeah, thank you very much. So there is some scope for optimism in the context of the importance of setting norms for space and responsible behavior in space, you think?
Certainly. It's just a question of whether we do it. We know to a first approximation, what needs to be done. We've done parts of it in the past. Think about the middle years of the 20th century, particularly the 60s, 70s. We had a giant burst of very interesting institutional innovations that don't get the credit and attention they deserve. The Antarctica Treaty, the Outer Space Treaty, the Limited Test Ban Treaty. Then we had the revamped law of the Sea Treaty. We had an international WHO-led eradication of smallpox effort. So there was this kind of globalist internationalism, which is very different than liberal internationalism, even though liberal nationalists in the United States all supported this stuff, and even though the United States and liberal internationalists in the United States played leadership roles in doing all of this, this was not really in any way something that was distinctively liberal, as evidenced by the fact that the Soviet Union was a major participation in this. So I see an important part of the spectrum of a kind of Westphalian 3-0 internationalism, where we can solve problems that we have in common and regulate these common planetary spaces without coming to agreement on how we configure our domestic politics. And I think that this is something that we need to always emphasize, that, you know, the Chinese are very modern in many ways, and they have liabilities, you know, in all of these different domains. They are as much the victims of these externalities and unintended consequences. So I think that there is, you know, a great potential that is not adequately tapped, and that we need to help that along by framing it properly and not mixing it and conflating with other types of internationalisms, however much we might personally like them.
Thank you very much. I don't know if Chris or Sonia would like to add one last question, because I'm aware we're running out of time.
On my side, actually, I've found this absolutely fascinating, and maybe to pick up on the last a thread of the last points, which is a lot of the emphasis when we talk about positive cooperative space has relied on lawyers and scientists, as if they're devoid of the politics that of participation and the like. And I'm wondering what you think about, I mean, Wernher von Braun, you know, once the rockets go up, who cares where they go down, you know? He hasn't asked that question. So I'm just wondering what you think about that, and whether I'm just being a little bit too contrarian here.
Well, a contrarian perspective, you know, is always going to be at least partially vindicated, given humans and their many foibles. But lawyers and scientists have been very potent, and particularly the scientists, with the case of the nuclear weapons, you know, arms control and the advocacy thereof was significantly a product of a group of nuclear scientists, you know, associated with the Bulletin of the Atomic Scientists in Pugwash. And I think it was appropriate that Pugwash received the Nobel Prize in Peace, because, you know, those meetings and those networks and the ideas that were developed played an important role in the end of the Cold War. You know, we see Mikhail Gorbachev and the circle of people immediately around him, particularly Velikov, his main science advisor, had been a member of Pugwash, you know, for a long time. And so coming up with a shared understanding and a shared normative perspective, when scientists do that, it can have sometimes a very significant effect. And we see also, I think, a great role for science as an influencer on the climate change issue. Obviously, we're not doing enough, but we wouldn't even know about this in any kind of actionable way without the advances of science and the scientists and their continuing presentation of these unfolding alternative Earths that we're creating is the indispensable first step to actually doing anything. And more generally on this point, I've become increasingly, as I said, I'm at the beginning, I guess it was in the green room phase, I'm very much immersed right now in writing a book about the planetary and world order, and coming around to the great importance of shared understandings. The reality is that we've reached a situation where the ability to coerce people is really diminished. I mean, look at Afghanistan, the United States, the Soviet Union, you know, Vietnam, you know, we're seeing this in Ukraine now. You know, traditional instruments of coercion, while they are obviously not gone and have some potency, just can't really deliver. That the veto power, the resistance power of actors is now extremely wide. There's been this distribution of power, this distribution of violence capability in various ways. And once you say that, then you have to say, well, solving any of these global problems is going to have the prerequisite that we're going to have to get pretty much everybody on board. And that the key step in doing that is to establish shared understandings. And so many of the people who think about the world order, these problems, are talking about world government in the sense of a world state, which seems to me to be extremely difficult to achieve, as well as undesirable in some ways. But we should have a world constitution. And we should start, and the world constitution would not authorize a world state, but a world constitution, in its first iteration, would be nothing but a set of shared understandings that we have all come to reach, and stating those in this authoritative and prominent way. So it is knowledge politics. It is narrative politics. It is persuasion politics, as the really only important vector for potential major change.
If I could just jump in. Thank you, Professor, for your very fascinating lecture. And my question kind of follows in from your comments on sort of world constitution and towards building this global normative structure, right? My question has more to do with, given the diversification of power in space activities and the increasing privatization, how do we, within the policy sphere, effectively mitigate terrestrial profit-driven colonization, especially given the popular appeal of the ideas as well as the personalities of space expansionists? Thank you.
Well, you certainly have put your finger on another key part of this mosaic, which is that there is this sort of charismatic appeal of this colonization scenario, and there is within the kind of technosphere among the those on the planet who are in the engineering and computer and other similar types of activities, and also read a lot of science fiction, that there is a sort of presumptive view that this is a really great thing to do. And I pointed this at the beginning of my talk, that there's this cosmic narrative that has been spun out, and that is extremely mesmerizing to people. It's the kind of thing that who could disagree with, in these people's minds. And so I think that that's a big factor that's going to continue to push this. And another part of it is science fiction. A lot of my slides were images from science fiction, and we have this enormous technological imaginary that's in science fiction. Science fiction really is the distinctive literary form of scientific technological modernity. And all along, science fiction has been tremendously influential. You go back to the beginning, to Tsiolkovsky, to Goddard, to von Braun, many of the astronauts, and they will all say that they became space enthusiasts by reading science fiction. Jules Verne and H.G. Wells, to a first approximation, hatched all of this. And so there is, again, this ideas politics. There is this kind of narrative that has been created and is continuously being reinforced. And, in my modest way, I'm trying to, say that, gee, this is not likely to end in the positive ways that you guys anticipate. You've got to look, at downsides. You've got to make far more prudent, assessments than this fictional vehicle commonly entails.